We've spent some time now solving and working with absolute value functions, and it's time to take the next step and actually explore the graph of an absolute value function. So I've picked an absolute value function for us to look at, got a grid, and I've got a table of values. And like anything, when we start exploring functions, it's nice to pick some values for x, plug them into the function and see what the function kicks out for y, plot those points and see if we can get a general idea of what the function will look like graphically. So when we explore looking at functions, it's always nice to look at some negative values. We always want to grab x equals 0, and then we want to explore some positive values too. So I'm going to just explore what happens between -3 and +3 when I plug those values in for x. So I'll do the first couple off here to the side so you can see my computation. Once we get a few of the way into it, I'm going to stop doing that. So we're going to plug in -3 in for x. So I get y equals the absolute value of -3 subtract 1 minus 2. Well, -3 subtract 1 is -4. The absolute value of -4 is 4. And when I subtract 2 away from that, I get 2. And this is a coordinate, -3, 2. So 1, 2, 3, 1, 2. Okay, I know that's a point on my graph. Now we're going to plug in -2. Y equals the absolute value of -2 subtract 1 subtract 2. Well, -2 subtract 1 is -3, and the absolute value of -3 is 3 subtract 2 is 1. So now that's another coordinate, -2, 1. So -1, 2, 1. Now if I plug in -1, so y equals the absolute value of -1 subtract 1 subtract 2. -1 subtract 1 is -2. The absolute value is 2. Subtract 2 is 0. So -1, 0 is a coordinate. When I plug in 0, now I'm going to stop writing them down. 0 subtract 1 is -1. The absolute value of that is 1. Subtract 2 is -1. And hopefully we see a pattern here emerging, so that will give us something to check back on. When I plug in 1, 1 subtract 1 is 0. The absolute value of 0 is 0. Subtract 2 is -2. And right now it appears very, very linear. And we're going to see if that continues. When I plug in 2, 2 subtract 1 is 1. The absolute value of 1 is still 1. Subtract 2 is -1. So 2, -1 is a point, and it no longer appears linear. When I plug in 3, 3 subtract 1 is 2. The absolute value of 2 is 2, and 2 take away 2 is 0. And it looks like I've got almost like a check mark going on. I'm going to try a couple more points and see what I get. So I'm going to plug in 4. 4 subtract 1 is 3. The absolute value of 3 is 3. Subtract 2 is 1. So when I plug in 4, I get 1. And it follows that pattern. And what I find here is I get a V. And what you'll find, you can continue plugging points in that table of values. You'll find that this will continue forever in that pattern, and going off this direction will continue forever in that pattern. It is indeed a V. Every absolute value function will have this shape. It'll always graph to be a V. And as we get down the road in exploring functions and exploring families of functions, we'll find a way to find this. This is called a vertex, where these two lines converge. Find a way to look at this function and identify, without doing this, where that vertex is going to be and how steep the V is going to be. So that's coming down the road. But for right now, we need to know that the graph of an absolute value is a V, and that we can find coordinates or points on the graph by plugging them into a table of values, doing the math, and seeing what the function kicks out for values of y.